Let's now answer this question together. So I have solved 2 cos of 2x equals negative the square root of 3 for negative pi to pi. The first thing I'm going to do is rewrite this, but divide both sides by 2. So that means on this side, I'm going to have this, and I'm actually going to rewrite my domain as that. So it's the same information, just represented in a different way. Now I'm looking at this and I immediately don't like that. So what I'm going to do is say, let 2x equal theta. So now I can rewrite it, but instead of 2x, I'm putting theta there, and then I'm going to get this. Now that I've done that, I also need to rewrite my domain in terms of theta. So how am I going to do that? Well, if I know that I'm dealing with 2x, I can make this 2x quite easily by timesing it by 2. And if I'm going to times that by 2, I also need to times each of these by 2. So negative pi times 2 is going to be negative 2 pi, and pi times 2 will be 2 pi. Now that I'm here, what I need to do is realize that 2x equals theta. So I could simply rewrite this again like this. So just like that, I now have everything in terms of theta, and this is what I'm going to be using to answer my question now. Perfect. So now I need to solve this trigonometric equation by figuring out what my theta value is going to be. And there are a few ways you can do this. You can think of your unit circle, or you could think of your special triangle. So if we look at our special triangle, we know that we're going to begin with an equilateral triangle with each side of 2. We're then going to cut it in half. That means now that instead of 2 there, it's going to be a 1 on each side. We know that this value here is going to be the square root of 3. This is going to be pi on 3, just 60 degrees. This is going to be half of that, pi on 6. So now looking at this triangle here, the one that we've cut in half, can we figure out for what value of cos is going to give me a value of the square root of 3 on 2? Let's ignore the negative for the time being. So if I was to go cos of pi on 3, and remember it's going to be adjacent on hypotenuse, so that's going to give me 1 over 2, so that's not any good. But what if I did cos of pi on 6? Well, adjacent would be square root of 3 and hypotenuse would be 2, so it's going to work. So that tells me that my reference angle is going to be pi on 6. But let's now remember that we have to find this, we need an output that is negative. So in other words, what it's going to be is over here and over here. So this one and this one. The way I like to think about it, instead of using the special triangle, is simply looking straight at your unit circle and saying, all right, I'm dealing with cos, that's my x-axis. I know I need to find where I get negative the square root of 3 on 2. I know that's going to be the furthest point away, and then you can simply draw your lines up and say, I'm going here and I'm going here. Hopefully you've memorized your unit circle and you simply know that when I'm dealing with a cos with a square root of 3 on 2, so that's my x value. So right here, that is negative the square root of 3 on 2. And here, this is negative the square root of 3 on 2. You can simply think of it in terms of that. And now you just need to think, all right, what is that going to be? Well, if I know my reference angle is pi on 6 and I'm in my second quadrant, it's simply going to be 5 pi on 6. And let me then get another color. If I'm trying to figure out what that to that is, again, if I know my reference angle is pi on 6 and I'm now in my third quadrant, it's going to be 7 pi on 6. I think that's the best way to think about it. You can use the special triangles if you want, if you're struggling to figure out what your reference angle is. But I think going straight in and just figuring out by looking at the unit circle what everything is going to be is a far simpler method to do it. But let me know what you think is the easy way to do it. So now that we're there, what we're going to say is, all right, we know that we have theta, and we know that we're dealing with 5 pi on 6 and 7 pi on 6, but let me not write them right there. Let me go 5 pi on 6 and 7 pi on 6. Now, the reason why I'm not writing them right here is because I know that my domain is between negative 2 pi and 2 pi. So that means I'm going to have to plus 2 pi and minus 2 pi to a few of these. So we know that to go right around my circle, from here all the way around, that's 2 pi. So obviously, if I were to add 2 pi to one of these values, it's going to take me beyond my domain. And I can prove this to you. If I was to take this value right here and plus 2 pi to it, what's going to happen is I'm going to end up with 5 pi over 6 plus, well, 2 pi is simply going to be 12 pi over 6. And that's going to get me 17 pi over 6. And that is bigger than 2 pi. So that proves that we can't go any more that way. But because our domain is negative 2 pi, it means we're going to have to move backwards. So meaning I'm going to have to go minus 2 pi and minus 2 pi. So I'm going to have to go 5 pi over 6 minus 12 pi over 6 and 7 pi over 6 minus 12 pi over 6. 7 pi over 6 minus 12 pi over 6, that is simply negative 5 pi over 6. Negative 5 pi over 6. And this one is simply going to be negative 7 pi over 6. And now I've got those. So that's how I got those results. So let me now rub that out. So now I've got all my values, and this is normally where people make the mistake. They just simply stop here. But remember, we have to have our final answer in terms of x, because our question was in terms of x. So now what I'm going to have to do is realize that, let me realize that 2 of x equals theta. So I could simply get rid of that and write 2 of x. But now I want x by itself, so I'm going to have to divide each of these by 2. And that's the same thing as timesing by a half. So what I'm going to end up with is 7 pi over 12, negative 5 pi over 12, 5 pi over 12, and 7 pi over 12. And just like that, we have answered the question. Hopefully this has been helpful to you in answering this question. We're now going to get stuck into this one. All right, so let's now answer this one. So we have tan of x we have tan of x plus the square root of 3 equals 0, and my domain is 0 to 2 pi. The first thing I'm going to do is rearrange. So this is going to be the same as if I have negative pi on 3. So now I need to figure out for what value of x am I going to get negative the square root of 3. What I'm going to do is draw myself a little bit of a unit circle. I'm actually going to come up here and steal this one. Let me come here, steal this, bring it down like that, get rid of all the marking inside of it. Whoops, too much. So I know, again, this is where I think it's really helpful to memorize your unit circle, because I know that for my tan, I'm going to have 3 values, 1, 2, 3. Remember, it's sine over cos, and I like to think about it in terms of gradient. This first one's going to be 1 over the square root of 3. This one's going to be 1, and this one's going to be the square root of 3. So as my numbers get bigger, that's obvious because my gradient is getting bigger. So now to figure out where I'm going to get negative the square root of 3, that's obviously just going to be over, whoop, let me try that again. It's going to be over here, whoop, let me try that again. It's going to be here. That's as good as it's going to get. So that's going to be negative the square root of 3. So just like this is the square root of 3, on this side, this is going to be negative square root of 3. And hopefully you can see I could follow this line, keep on going down. This is also going to be negative the square root of 3. So you can see I'm going to have answers in both my second and fourth quadrant. So first I would do is figure out what my reference angle is going to be. So in my first quadrant, what is this angle going to be? And we know that's going to be pi on 3. Pi on 3. So now I just need to figure out what it's going to be in the second and fourth quadrant. So in my second quadrant, I know that pi on 3 is going to be 2 pi on 3. And in my fourth quadrant, I know that pi on 3 is going to be 5 pi on 3. So my answer is simply going to be 2 pi on 3 and 5 pi on 3. So this one's far simpler than the one we saw above. And hopefully all of that made sense.